This Zoom session is being brought to you by the fractal Octaves Z. Yesterday was Octaves S. This is kind of a backwards system. Again, one of my favorite fractals. All right. Today we will be doing 2.5 and 2.6, thus finishing chapter 2. And so therefore chapter 2 will be due, I guess, by the end of next week. And or next Thursday, whatever. And also 2.6. 2.6 phase shift. Monday we'll cover 3.1 and 3.2, and then afterwards it'll be one section of class. Okay, 2.5 is about graphing secant, cosecant, tangent, and cotangent. Now these are the other four trig functions, and unlike sine and cosine, they involve dividing by a sine and cosine or cosine, and therefore they periodically go through infinity, which makes their graphing a little awkward. Because they always have, as you can see right here, you have these asymptotes, periodic asymptotes. So for example, secant, that's 1 over cosine. And since cosine is 0 at integer and a half multiples of pi, and plus or minus 1 at integer multiples of pi, then secant of n and a half pi is infinity, and secant of n pi is negative 1 to the n. So if you imagine the cosine graph going up, down, up, down. Every time cosine goes to 0, secant goes to infinity, and otherwise makes this a U-shaped graph here, and then upside down U, and upside right side up U, and so on. Period 2 pi. You move over 2 pi, you wind up with the same graph. Cosecant is 1 over sine, so it's infinity whenever sine is 0, which is at integer times pi, and it's at plus or minus 1, and when sine is at plus or minus 1 at integer and a half times pi. So cosecant of integer times pi is infinity. Cosecant of integer and a half times pi is negative 1 to the n. It goes to infinity at 0, pi, 2 pi, minus 2 pi, and so on. And again, and rather like the secant graph, this is the graph form these use upwards U's and downwards U's, and upwards U's and downwards U's. Again, repeating with period 2 pi. Tangent is sine over cosine. So when sine is 0, tangent is 0, and that's at integer times pi. And when cosine is 0, tangent is infinity, that's integer and a half times pi. So tangent n pi is 0, tangent of n and a half times pi is infinity for any integer n. So it would go through 0 here, and here, and here, and here, and here, and halfway between the zeros, it goes to infinity. And it has this kind of N-shaped graph always rising. It never stops. It just sort of slows down a bit at 0. Sort of like the way I drive through the toll booth at the Bay Bridge. Slow down just a little bit and then accelerate outwards. And it's always rising, and tangent has period pi. So we take this N-shaped graph and shift it left and right by integer multiples of pi, and that's the graph. Cotangent is cosine over sine. It's 0 when cosine is 0 at n and a half times pi. It's infinity when sine is 0 at n pi. And if you take the reciprocal of this, you get this. And cosine graph is constantly rising. Cotangent graph is constantly falling. If you imagine this graph kind of wrapping this graph paper around at infinity, so the upper edge meets the under edge, you get kind of spirals infinity, and this one spirals the opposite handedness. And again, I was falling, and like tangent has period pi. Now, if you multiply x by omega, that speeds it up by a factor omega. And secant and cosecant have period 2 pi. So secant omega x and cosecant have period 2 pi. Tangent has cotangent pi. So tangent x and omega x pi over omega. So that's some examples of. And by the way, if you have a graphing calculator, all these problems you can basically do with a few push buttons. And I recommend you learn how to do some. So graph y equals tangent pi over 2x. The period is pi over omega, which is pi over pi halves. That's 2. So here I recommend drawing a table when x is 0. 0 times pi halves is 0, 10, 0 is 0. So we have a 0 here. And period 2 means that at 2 and at 4, it's 0. And midway between the zeros are the infinities when x is 1 and x is 3 and so on. 0, 0, 0, 0, and so on. And in between them, infinity, 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 infinity. And as before, tangent is constantly rising. You have this N-shaped graph. Cotangent of 1/4 x, period is pi over omega, pi over 1/4. Therefore, 4 pi. And again, the table, when x is 0, the cotangent of 0, which is infinity. And okay, period 4 pi, so at 4 pi, it's infinity. At 8 pi, it's infinity. And in between the infinities of the zeros, 0, 2 pi, and 6 pi, and 10 pi, and so on. So at 0, 4 pi, 8 pi, minus 4 pi, minus 8 pi, you get these vertical asymptotes. It goes to 0 midway between the asymptotes. And it's constantly falling in this. Here's graphing y equals 2 secant x. All right. Period omega is 1, period is 2 pi over 1, which is 2 pi. Now, okay, we do a graph. We do a table first. When x is 0, twice secant 0, that's 2 over cosine 0, which is 2 over 1, which is 2. This 2 kind of gives you, so to speak, an amplitude of 2. And again, we end period 2 pi. So 2 here, at here 2 pi, here 4 pi. There's a half period identity. At a half period with pi, it goes from 2 to minus 2, to plus 2 to minus 2, to plus 2. In between the plus and minus 2s are infinities. Here at pi halves, 3 pi halves, 5 pi halves, 7 pi halves, and so on. So at 0, we put a 2. At pi, we put a negative 2. At 2 pi, we put a 2. At 3 pi, we put a, that really should be a 4 pi. Excuse me. Page, excuse me, I made a mistake here. 6, number 1, 4 pi. And is that right? Let me double check that. No, it's not right. It's good the way it is. All right, and between the pluses and minus 2, there'll be infinities. You have now this is a little more complicated. Y equals secant 3 halves x, 3 pi halves x plus 2. This plus 2 means we lift it 2 units after we do all the rest. And the period is 2 pi over 3 pi over 2, which comes up to 3. All right, now, okay, because of the lifting 2 units, that, well, you get the secant graph. It's at 0, it's 3. 3 units later, it's also 3. 3 units after that. At 3 halves, well, if you throw it in here, 3 halves, you get well, half a period later, it'd be this would be a negative 1 plus 2 is a positive 1 because we're lifting it by 2 units. And in between the 3s and the minus and the 1s, you have your infinities. So it looks like this. Here we have secant 2 pi x, 2/3, 2 pi thirds x, that plus 2. Again, we lift 2 units, and this is a period of 3. I see that this is my, how did this happen? I do believe I did this twice. You know what? I think I'm going to have to delete this section, this problem. 7, delete. Okay, my error. All right. Yeah, I am going to delete this page in the canvas. Okay, so there we have this.